Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International GCSE Chemistry Paper 1C for January 2023. Let us begin with the first question. Question 1. This question is about the three states of matter, solid, liquids and gas. The diagram shows how particles of a substance are arranged in two of these states. So there is a solid state and the gaseous state. You can see in the solid state there is a regular arrangement. The particles are closer and touching, while in the gaseous state they are farther apart. So they say, complete the diagram to show how particles are arranged in liquid state. In liquid state, the particles are not in a regular pattern, so they are more disorderly, but they are not as far apart from each other as we see here. So this is a fair representation. The next part says, identify the state of matter that contains particles with the least energy. This is going to be the solid state because they have less kinetic energy and there is less vibration. In part B, the table shows two changes of state. Complete the table by giving the name of each change of state. So a change from solid to liquid is melting, and a change from solid to gas is sublimation. In part C, explain why hot water evaporates more quickly than cold water. This is because the particles in hot water have more kinetic energy, so the intermolecular forces of attraction between them are easily overcome or they are easily broken. So this brings us to the end of question 1. Let's continue to question 2. Question 2, this question is about elements, mixtures, and compounds. Which of these is the formula of a molecule of an element? A molecule of an element is going to be chlorine because this is a compound, that is a compound, and this is not a molecule. So B is the only correct answer. In part B, which method can be used to separate an insoluble solid from a liquid? An insoluble solid from a liquid, you're going to separate it by filtration. The next part says, give the name of a method used to separate a mixture of liquids with different boiling points. This is liquid, so we have a plural, meaning we're going to use fractional distillation, not simple distillation because there are two liquids which are to be separated. In part D, a student adds a crystal of substance X to some water in a beaker and leaves the beaker for 1 day. The diagram shows the beaker immediately after adding the crystal and after 1 day. So we see immediately and after 1 day everything has disappeared. So they ask, which equation gives the correct state symbols for a process that occurs in the beaker? So in the beaker, we can see there was a solid that has become aqueous. So this should be your correct answer. The next part says which other process occurs in the beaker. The next process is going to be diffusion because this solid is going to dissolve, and then the dissolved particles are going to be carried around in order to create a solution of uniform concentration. So here I say diffusion. The next part says, after 1 day, the student does 2 tests on the liquid in the beaker. The table shows the student's results. A flame test was carried out and a lilac flame was observed. And then, addition of acidified barium chloride solution, a white precipitate was formed. This confirms presence of a sulfate anion. Remember, when you are testing for sulfate anions, you add a specific acid, for example, hydrochloric acid, followed by barium chloride. Observation of a white precipitate confirms presence of a sulfate. Then finally, they said identify substance X. Because X contains potassium cation and sulfate anion, it's going to be potassium sulfate. So this brings us to the end of question 2. Let's continue to question 3. Question 3. This question is about gases. Name the gas that contains about 1% of dry air by volume. This gas is going to be argon. Then the next part says, which is the most abundant gas in dry air by volume. This is going to be nitrogen. And next, a student uses this apparatus to find the percentage by volume of oxygen in a mixture of oxygen and neon. So this is where we have oxygen and neon. Then we have the wet iron wool. Of course, this could be rusting. If rusting takes place, oxygen is going to be used up and then water is going to fill the space that was occupied by oxygen. So they say this is the student's method. Measure the initial length of the column of gas in an inverted test tube, and then leave the test tube in the beaker for a week. Then measure the final length of the column of gas in a test tube. So they say some of the iron will rusts. Give the chemical name for rust. The chemical name is hydrated iron trioxide. Next they say give a reason why neon does not react with the iron will. This is because neon has a full outer shell. In the next part, the table shows the student's results. So we have the initial length of the column, which is that, and the final length of the column, which is that. They say use the results to calculate the percentage of oxygen in the mixture of oxygen and neon. The height or length occupied by oxygen is going to be 75 minus 30, giving us 45. So the percentage is going to be 45 divided by 75 times 100, which is 60%. And therefore, this should be my answer. So this brings us to the end of question 3. Let's continue to question 4. Question 4. A student uses this apparatus to investigate the dyes of food coloring A. So this is the setup. We see the chromatograph paper, there is water, and then a baseline drawn in ink. They say explain 2 mistakes that the student makes when setting up the apparatus. The student has drawn the baseline in ink. This is going to be disadvantageous because the ink is going to interfere with the dyes that you're trying to separate, or there will be some contamination. So the results are going to be contaminated because color from the ink is also going to be carried by the solvent. And then mistake number 2, the baseline is below the water level. This is a disadvantage because the ink may wash off into the water. So I say the baseline is below the water level. Substance A will mix with the water and wash off the chromatograph paper. Moving on. In part B, the student repeats the experiment but with no mistakes. The table shows the RF values for 2 dyes of food coloring A. So the blue dye is at 0.5 and the yellow dye is at 0.25. They want you to complete the chromatogram for food coloring A by adding and labeling the dyes. RF value is equal to distance moved by the sample divided by the distance moved by the solvent. So if the blue dot is at 0.5, it's going to be halfway the distance where the solvent front is. Yellow dye is a quarter from the baseline and 3/4 from the solvent front. The next part says, give a reason why the blue dye has a larger RF value than the yellow dye. If it has a larger RF value, that means it's more soluble in the solvent, which is water. So because the blue color is more soluble in the water than the yellow food color. So this brings us to the end of question 4. Let's continue to question 5. Question 5. A student investigates the reactivities of 4 metals, aluminium, magnesium, copper, and metal X. The student adds pieces of magnesium ribbon to aqueous solutions of sulfates of each metal. After a few minutes, the student removes the pieces of magnesium ribbon and records the appearance of each piece of magnesium. So we can see the results in the table. With aluminium sulfate, there is a gray coating on magnesium. That means aluminium has been displaced. And then with magnesium sulfate, there is no change, meaning magnesium cannot displace itself. With copper 2 sulfate, a brown coating on magnesium, that means copper has been displaced. And with sulfate of metal X, there is a gray coating on magnesium. This also shows that there is a displacement. So the first question says, name the substance that causes the brown coating on magnesium. That is going to be copper metal or copper solid. State why there is no change with magnesium sulfate solution. This is because magnesium can't displace itself. In part B, the student repeats the experiment with pieces of metal X instead of pieces of magnesium. Table 2 shows the student's results. So we see with aluminium sulfate, there is no change, and that means aluminium couldn't be displaced, so aluminium is more reactive than X. Then with magnesium sulfate, there is no change. That means magnesium couldn't be displaced, so magnesium is more reactive than X. With copper 2 sulfate, there is a brown coating on the metal. This means copper has been displaced, so X is more reactive than copper. With sulfate of metal X, there is no change. This is because X can displace itself. So here we can see Aluminium and magnesium are more reactive than X, but copper is less reactive than X. Use information from both tables to deduce the order of reactivity of aluminium, magnesium, copper, and X. The most reactive is going to be magnesium because, of course, magnesium is higher than aluminium in the reactivity series. And the least reactive is going to be copper. So X lies in between aluminium and copper. So they say give a possible identity of metal X. X could be zinc, X could be iron, whichever you choose between aluminium and copper in the reactivity series. Then in part C, this ionic equation represents the reaction between magnesium and aluminium nitrate. So this is the reaction. They say, explain in terms of electrons which species acts as a reducing agent in this reaction. A reducing agent loses electrons. So that means magnesium is going to lose electrons to become Mg2+. So magnesium is a reducing agent because it donates electrons to aluminium 3+, causing it to be reduced to aluminium. So this brings us to the end of question 5. Let's continue to question 6. Question 6. This question is about polymers. This is the structure of a monomer, which we have here. They ask, what is the name of this monomer? This monomer is an alkene, so this is out, that is out. But this alkene has 2 carbons, so propene is out. It means this is going to be chloroethene, which is that. In part B, complete the equation to show the repeat unit of the polymer that forms from this monomer. To draw the repeat unit, the double bond is going to disappear and then we form 2 extensions on either side and then put square brackets like we see here. In part C, a typical molecule of the polymer has a relative molecular mass, which is that. Show that the number of monomer molecules needed to make this typical molecule is about 40,000. So I went to the repeat unit and I saw there were 2 carbons, 3 hydrogens and 1 chlorine. And when I added up each, I got 62.5. Meaning this polymer is going to be made by many molecules of this. So to find out how many molecules are, divide this number by that number. So I got 39840. And since this is approximately close to 40,000, this is my proof. So they're going to be 39,840 molecules. Moving on. In part D, these are 2 methods used to dispose of polymers: burying in landfill sites and burning. Discuss the environmental problems caused by these 2 methods of disposal. If we bury in landfills, the polymers are going to remain for a long period of time because they are not biodegradable. But if we burn, some toxic gases could be produced, as well as releasing huge amounts of carbon dioxide, which is a greenhouse gas, and global warming could result. When we go down here, a different polymer molecule contains 10,600 atoms of carbon, 10,600 atoms of hydrogen, and 31,800 atoms of chlorine. Determine the empirical formula of this compound. So the ratio is going to be carbon to hydrogen to chlorine, which is 10,600, 10,600, and 31,800. Since these are smaller, I'm going to divide that by that, which is that by that, which is that, and that divide by 10,600, which gave me 3. So the empirical formula should be 1 carbon, 1 hydrogen, and 3 chlorines. And this is going to be the answer. I can also write it here as CHCl3. So this brings us to the end of question 6. Let's continue to question 7. Question 7. The table shows the displayed formulae of some organic compounds. So we have this one here, that one, this one, and that. They say give a reason why X is not a hydrocarbon. This is X. X has oxygen, yet hydrocarbons contain only carbon and hydrogen. So it contains oxygen, so it's not a hydrocarbon. Then they say give the letter of the compound that is a saturated hydrocarbon with empirical formula CH2. So since we are looking for saturated, this is out. And we are looking for hydrocarbon, this is out. So we are left with 1, 2, 3. And since we are looking for a hydrocarbon that has empirical formula CH2, it cannot be this straight chain alkane, and it cannot be that. So it's going to be the cyclic alkane, and therefore my answer is W. The next part says, give the letter of the compound that produces 9 molecules of water when 1 mole undergoes complete combustion. In 9 water molecules, we have 18 hydrogens. So I'm looking for something that has at least 18 hydrogens, or at least a multiple of that. So this is going to be V, because V has 18 hydrogens around it. And in part D, give the structure formula of compound Y. Compound Y is going to be CH2 double bond CH, CH2 CH3, as we can see here. Moving on. In part E, explain why compounds W and Y are isomers. Let's go back to W and Y. This one here and this one here. I'm going to count the number of carbons. We have 1, 2, 3, 4. 1, 2, 3, 4. Then the number of hydrogens are 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So these two compounds contain the same molecular formula, but they have different structure formulas, so they are isomers. In part F, compound Z reacts with bromine in the presence of ultraviolet radiation. Write a chemical equation for this reaction. So compound Z has 4 carbons and 10 hydrogens. When it reacts with bromine, a substitution reaction occurs whereby 1 hydrogen is substituted by Br to form HBr on the other side. So the product is carbon 4 hydrogen 9, Br plus HBr. Then what is the name of this type of reaction? This is a substitution reaction. In part J, describe how the combustion of sulfur-free petrol in a car engine produces gases that can cause acid rain. Do not refer to carbon dioxide in your answer. So because this is sulfur-free, it means we cannot form oxides of sulfur. So we're going to work with oxides of nitrogen. So because air contains nitrogen and oxygen, at high temperatures in the car engine, these two gases react with each other, forming oxides of nitrogen, which are NOx. So these oxides of nitrogen can react with water or dissolve in water, forming acid rain when it rains. So this brings us to the end of question 7. Let's continue to question 8. Question 8. This equation is about ionic compounds. The table gives the formulae of some positive and negative ions and the formulae of some compounds containing these ions. So they say complete the table by giving the missing formulae. When sodium ion reacts with chloride ion, we get sodium chloride. Here we have magnesium chloride. Because this is 2 plus, the 2 is going to go to the Cl. And this is going to be magnesium nitride, Mg, 3 and 2. Give the name of the compound with the formula MgO. This is magnesium oxide, which is that. Then calculate the relative formula mass of sodium nitride. This is going to be 3 sodium, so 3 times 23 plus 1 nitrogen 14, giving me 83. Moving on. In part B, the diagram shows the arrangement of electrons in atoms of lithium and in an atom of oxygen. So we see lithium, lithium, and then oxygen. They say describe the changes in the electronic configuration of lithium and oxygen when these atoms form lithium oxide. During the formation of lithium oxide, each of the lithium atoms is going to lose 1 electron to become lithium ion, and its configuration is going to change from 2,1 to 2. Then oxygen is going to gain the 2 electrons, and its configuration is going to change from 2,6 to 2,8. Down here they say lithium oxide has a giant ionic structure. Explain why lithium oxide has a high melting point. So lithium oxide is a giant ionic structure containing multiple oppositely charged ions, meaning cations and anions. So the strong electrostatic forces of attraction between the ions require more energy to be broken, and that is why it has a high melting point. So this brings us to the end of question 8. Let's continue to question 9. Question 9. This question is about substances that contain covalent bonds. The diagram represents a molecule of oxygen. So this is the molecule of oxygen. They say, describe the forces of attraction in a covalent bond. covalent bond is an electrostatic force of attraction between the two nuclei and a pair of shared electrons. And down here, in part B, the table shows the boiling points of 3 group 7 elements. So the boiling point of fluorine is the lowest and that of bromine is the highest. Then they say, explain the trend in boiling points. We can see that the boiling temperature increases as you go down the group. And this is because there are more electrons, or you could say the atomic mass increases. So I say down the group, boiling point increases. So there are more intermolecular forces because the number of electrons increase. So more energy is needed to separate the molecules. That is why here we see bromine with a higher boiling point and fluorine with a lower boiling point. Moving on. Next they say, graphite is a naturally occurring form of carbon. Explain why graphite is soft and conducts electricity. They want you to refer to the structure and bonding in your answer. In graphite, each carbon atom is bonded to 3 other carbon atoms, leaving an unpaired electron. The structure in graphite is layered. In between the layers, there are weak forces of attraction, and these allow for the layers to slide past each other. So, graphite has a layered structure with weak forces of attraction between the layers. These layers can slide over each other. In graphite, each carbon atom is bonded to 3 other carbon atoms, leaving an unpaired electron per carbon. And these localized electrons conduct electricity when a potential difference is applied. So this brings us to the end of question 9. Let's continue to question 10. Question 10. A student uses this apparatus to record the maximum temperature in the reaction between solutions of hydrochloric acid and sodium hydroxide. This is the student's method. Add 25 centimeters cubed of hydrochloric acid to the beaker. Then 25 centimeters cubed of sodium hydroxide to the beaker. Then you stir and record the maximum temperature reached. The first question says, name a suitable piece of apparatus to add 25 centimeters cubed of solution to the beaker. Here we need to use a measuring cylinder because we want to add as fast as possible. So I wrote measuring cylinder. Moving on. In part B, before the reaction, both solutions have a temperature of 21 degrees Celsius, and the heat energy change Q for the reaction is 2880 joules. They want you to calculate the theoretical maximum temperature reached by the mixture, which has a mass of 50 grams. The specific capacity is 4.2 joule per gram per degree Celsius. Q is mc delta T, and 2880 is equal to the mass, which is 50 times 4.2 times delta T. Delta T is equal to 2880 divided by that, giving me 13.7. Since the initial temperature is 21 degrees Celsius, so the final temperature is going to be 21 plus 13.7, giving us 34.7 degrees Celsius as that. The next part says, give a reason why the maximum temperature recorded by the student is lower than the theoretical maximum temperature calculated. This is because heat losses to the surrounding occurred. And down here, in the reaction, 0.0500 mole of hydrochloric acid completely react. Calculate the molar enthalpy change in kilojoules per mole of hydrochloric acid. They want you to include a sign in your answer. So we know delta H is going to be Q over N, but this was an exothermic reaction, so we put a negative. Also, the Q we were given is 2880 joules. I have to convert that to kilojoules. That is why I multiply by 10 power negative 3, and then divide by the number of moles. So this gave me negative 57.6 kilojoules per mole, and this is my answer. So this brings us to the end of question 10. Let's continue to question 11. Question 11. This question is about the reaction between magnesium and dilute nitric acid. A student reacts dilute nitric acid with an excess of magnesium powder as the first step in preparation of dry crystals of hydrated magnesium nitrate. This is the equation for the reaction. So we have magnesium plus nitric acid giving us magnesium nitrate and hydrogen. And here they said excess magnesium powder was used. So this is going to be excess to ensure that all this reacts. And in the end, we're going to have only one soluble product, which is the major product. So they say, explain why it is important then magnesium is in excess. This is to ensure that all the nitric acid reacts so that the solution only contains magnesium nitrate, and you know magnesium nitrate is the desired product. In the next part, the student adds 0.75 grams of magnesium to 0.025 mole of nitric acid. Calculate the mass of magnesium in grams that remain at the end of the reaction. So here I'm going to calculate the number of moles of magnesium. Moles of magnesium should be mass divided by atomic mass, which is 24. So that gives us that as the moles of magnesium. But when I use the mole ratio, moles of magnesium that react should be a half the number of moles of nitric acid. So that means if these are the moles of nitric acid that reacted, half of these should be the number of moles of magnesium that reacted, which should be that. So the difference, meaning the remaining moles, should be that minus that, which is represented here, giving me that. So these are the moles of magnesium remaining. So the remaining mass should be this number of moles times the atomic mass, which gave me 0.45 as my answer. Moving on. Here they say, describe how the student can obtain dry crystals of hydrated magnesium nitrate from the mixture at the end of the reaction. Since we are looking for hydrated, you can filter the mixture to remove the excess magnesium. Remember, magnesium was excess, so some solid is going to remain as all the nitric acid is reacted, and the solution is going to contain only the desired product, which is magnesium nitrate. And then heat the solution in an evaporating basin until crystals form on a glass rod, or you could say until saturation point. Then allow the solution to cool down so that crystals can form fully, and filter to remove off the excess liquid. Then leave the crystals to dry, you could say air dry, or you could part the crystals dry using a filter paper. Moving on. In part B, the student repeats the experiment and records the volume of hydrogen gas collected. The graph shows the student's results. So we can see volume of hydrogen and then the time. They say use the graph to calculate the rate of reaction in centimeters cubed per second at time is equal to 40 seconds and show you're working on the graph. So draw a tangent at time is equal to 40 and then find the gradient of that tangent. I used this point as well as that point. If I can make it bigger, you can see I used this point here and that point, which are 28 to 05 and 52 to 75. So my gradient was 275 minus 205 divided by 52 minus 28 as my gradient. The allowed answer is between 2.75 to 3.75. So this brings us to the end of question 11. Let's continue to question 12. Question 12. This question is about hydrated compounds. Crystals of hydrated barium chloride, which is that contain water crystallization. A student uses this apparatus to remove and collect the water from some crystals. So we see there is barium chloride crystals. These are heated and then water comes off. This water is going to be condensed and then collected. So here they say, this is the student's method. In step 1, record the mass of tube A when empty. Step 2, place a sample of hydrated barium chloride crystals in tube A and record new mass. Then step 3, heat tube A. Step 4, allow tube A to cool and record the mass. Then repeat 3 to 4 until the mass recorded in step 4 is constant. These are the student's results. So mass of the tube A is going to be that. Mass of the tube plus the hydrated barium chloride is going to be that. And the final mass of tube A and barium chloride, which is anhydrous, is going to be that. So they say, give a reason why the student repeats step 3 and 4 until the mass is constant. This is to ensure that all the water evaporates. And they say calculate the mass of barium chloride that forms in tube A. This is the mass of anhydrous barium chloride, which is going to be the mass of tube A and barium chloride minus the mass of tube A alone. So 15.75 minus 10.55, which gives me 5.20 grams. And then calculate the mass of water lost. So the mass of water lost is going to be you could do that minus that, or you could do the other way around like I did here. So either way, you're going to get the same answer. Here, I first calculated the mass of the hydrated alone, which is that, and then hydrated minus anhydrous gave me this. However, you can also do it the other way around by getting the hydrated and tube minus anhydrous and tube. That still gives you the same answer. So which is going to be 0.9 grams. The next part says, determine the value of X in the hydrated barium chloride. Show you're working clearly. So when this is heated, everything breaks down and we get barium chloride and water. So it means the mole ratio is going to be 1 to X. So we can find the value of X by getting the number of moles and then looking at the mole ratio. So moles of barium chloride, which is the anhydrous, since we already have the mass, the moles are going to be 5.2 divided by the molar mass, which is 208, giving us that. If I can take you back, we see this is the mass already. And then the moles of water are going to be the mass of water divided by that, which gives us that. So the ratio is going to be 0.025 to 0.05, which is 1 to 2, and therefore the value of X is going to be a 2. Down here they say, describe a physical test to show that water in tube B is pure. Here you need to determine the boiling point of the water. If it boils at 100 degrees Celsius, then it is pure water. In part C, a sample containing 0.02 mole of hydrated copper 2 sulfate is heated using the same apparatus. The products of the reaction are anhydrous copper 2 sulfate and water. This is the equation for the reaction. This is a reversible reaction. Then, describe how the reaction can be used to show that a liquid contains water. You need to use anhydrous copper 2 sulfate. And then if the color changes from white to blue, then that is proof that the liquid contains water. And finally, calculate the maximum number of water molecules in tube B after the sample of hydrated copper 2 sulfate has completely reacted. Remember, 1 mole of any substance is 6 times 10 power 23 particles. Since the moles of the hydrated copper sulfate are 0.02, it means the moles of copper sulfate are also 0.02. So the moles of water are going to be 5 times that, giving us 0.1 mole. So the number of molecules is going to be the number of moles times that, giving us 6.0 times 10 power 22 molecules. And this is my answer here. So this brings us to the end of question 12, as well as to the end of this paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.